Chapter 11, Video 2. In this lecture, we're going to talk about Mobitz 1 second degree AV block. Mobitz 1 is often referred to as the second degree AV block, and we will see it called WinkyBok. W-N-W-E-N-C-K-E-B-A-C-H. So if you hear the term WinkyBok, that is the same thing as Mobitz 1 second degree. So you may hear these two terms used interchangeably, okay? WinkyBok is a type of a second degree heart block. With WinkyBok or Mobitz 1 second degree, I'm going to tell you I'm old school, so I learned it as WinkyBok. Like I said again, you may hear it used both ways. I commonly refer to it as WinkyBok. It's out of habit. So, you know, do know we're talking about the same thing. But with WinkyBok, it's usually a transient block lasting only a few days. What happens here is the AV node, it becomes progressively weaker, and it's finally unable to send that impulse. So a lot of times we'll start out with that first degree heart block, and that first degree heart block will progress to that second degree heart block. So the AV node gets weaker, and it becomes less able to conduct that impulse down to the ventricles. So with WinkyBok, the PR intervals grow progressively longer until there is a P wave that is not followed by a QRS. So you'll see with WinkyBok, we'll have our P wave, we'll measure our PR interval, and our PR interval in one section of the strip may be shorter, and then as you move down the strip, the PR interval on the next cycle gets a little bit longer, and then on the next cycle it becomes a little bit longer, and then finally it's dropped. That beat is dropped, and we have one that's not followed by that QRS because it doesn't get through. WinkyBok is characterized by the gradually prolonging PR interval, and then we finally drop that beat. With WinkyBok or Mobitz 1 second degree, we have an atrial rate of 60 to 100. The ventricular rate varies. The ventricular rate is less than the atrial rate, and this is because we have that non-conducted beat. Remember, I said that PR interval grows longer, that signal is sent, and it takes a little longer to get to the AV node, and then the next signal takes a little bit longer to get through the AV node, and then the next signal takes a little bit longer than that to get through the AV node, and then all of a sudden the AV node on the next signal, it says, no, you're not going through. So that signal doesn't get through, and those ventricles do not contract. And when those ventricles don't contract, that makes our ventricular rate vary, okay? With regularity, we have irregular. We have groups of beats, and then we have that pause. That hallmark of WinkyBok is that group of beats and then that pause. So having that pause and having that gradually prolonging PR interval, that is the hallmark of WinkyBok. That's how we know we're dealing with WinkyBok. The P waves are upright, matching, and then we have one blocked with no following QRS, okay? So the P waves, they're all the P's look the same, they're all there, but then we have that prolonged PR interval. The PP interval here is regular. With WinkyBok, we want to look for that footprints in the sand. And what we mean by that is that P wave that's hidden inside of those QRS complexes. And I can go over that with you when we start going over the different strips. But again, the characteristic of WinkyBok is that prolonged PR interval, and then we have that lost beat. The QRS is less than 0.12 seconds. The causes of WinkyBok, again, could be an MI, a myocardial infarction, digitalis toxicity, or different medications. We usually do not have any adverse effects, but we want to watch for worsening with this block. With WinkyBok, we usually don't need to treat it. We may prepare for transcutaneous pacing if the person starts experiencing a decreased cardiac output, and if the heart rate gets too low, we may give atropine. We may give atropine if pacemaker not immediately available, and the patient is symptomatic, but most of these patients just require observation. So when we go over and we look at this strip with WinkyBok, we're going to ask ourselves the same 5 questions that we learned previously in the previous lectures of diagnosing a strip. So the first question is, are there QRS complexes? They're all shaped the same here. So we do have QRS complexes. They're all shaped the same. Our regularity is irregular. We have a heart rate range of 50 to 83 with a mean rate of 70. The P waves here, they match, they're upright, but some are not followed by the QRS, okay? And the PP interval here is regular. We have an atrial rate of 83. The PR interval varies from 0.04 seconds to 0.28 seconds. So this goes to show us that it's WinkyBok. All right, so let's talk about these P waves and what we mean by the footprints in the sand. So we have P, QRST, P, QRST, P, QRST, P, and then we don't have a QRS here. And then we go on down and we have a P, which is really close to the QRS. They march out, but they're hidden, okay? So if we measure our PP intervals, they're going to be close to the same, but look at our PR interval. The key that we want to look at here with WinkyBok is our PR interval. From here to here is 1, 2, 3, 4 little blocks. We go down, we have 1, 2, 3, 4, 5, 6 little blocks. 1, 2, 3, 4, 5, 6, 7 little blocks. And then notice we have our P wave, and then we have 1, 2, 3, 4, 5, 6. We got 5, 10, 15. We got about 20 little blocks. So we lost our beat here. This is where we lost our beat. And then we start over. This P wave is really close to the QRS, and then here it's getting longer here, and then we lost our next beat. So this is an example of WinkyBok. If you have any questions about this, please let me know. That's it for video 2. I will be coming back on the next video talking about Mobitz 2 with a 2nd degree AV block. But for this video, that is all we're going to do. But if you have any questions, please let me know.